Okay, well, hello everyone and welcome. Thanks for joining us for today's webinar, AI Eats Big Data for Breakfast. I'm Ted Howard and I'm the managing editor of iTreasurer, a leading provider of information for corporate treasurers. I also help run several Treasury peer groups for iTreasurer's parent company, NeuGroup. For more than 20 years, NeuGroup has been a trusted thought leader for global finance and Treasury professionals. We run a network of member-only peer groups covering senior-level executives, functional and regional treasurers, as well as finance. We now have 18 groups cutting across sectors, finance functions, and global regions with more than 450 members from 200+ companies. Today, we're joined by John Young, Chief Data Officer at C2FO, Guru Kirthgavasan, Engineering Program Manager at Treasury at Microsoft, and Jordan Novak, Managing Director of C2FO. John, starting with you, why don't you tell us a little briefly about what you do at C2FO, and then Jordan and Guru, you can follow up.
Sure, thanks, Ted. John Young. I own all of the end-to-end data services for C2FO. So from a functional perspective, that's back-end technology and data architecture with a data engineering core that's some embedded analytics services through data science and machine learning teams. But our ultimate goal is to provide value for the business by supporting new products and services, supporting the data consumers in the business, which means we have to basically ensure that the data flows through very smoothly and people are able to use it to make more informed decisions about the data. So that can be new innovations around new products and services. That can be optimizations at scale. It could be behavioral targeting from a sales and marketing perspective. But fundamentally, it's the end-to-end data services we provide.
Terrific.
Yeah, thanks, Ted. This is Jordan. Jordan Novak. I'm a managing director here at C2FO, former corporate practitioner. So I worked in corporate finance and treasury at Dell for most of my career, and now I work with predominantly global 100 organizations, working with them in the treasury space to help them optimize what they're doing. Guru?
Yeah, hi. Good afternoon. My name is Guru Kirthgavasan. I am a program manager here at Microsoft Treasury. I've been with the company for close to 10 years, and what I do at Treasury is to take Microsoft Treasury onto the cloud, which we did a couple of years back. And now we are working to build and rebuild some of the applications that we have on the cloud, also as software as services. And during this process, we've had a chance to bring in a lot of modern technology into Treasury, like machine learning, chatbot, etc., which I'm pretty excited to show you today.
Okay, excellent. Thank you, guys. Before I hand things back to John, I'd like to go over a few housekeeping notes. First, I encourage you to submit any questions you have through the questions box, which will be in the toolbar. Depending on the volume and nature of these questions, we'll try to answer them today, but if due to the number of participants on the call, we may not get to all of them. So if we don't answer your question on this call, someone can follow up with you directly. Also, an email will be sent to all registrants containing a link to review the print-friendly version of today's slides as well as a recording. So without further delay, John, why don't you start us out?
Okay, thanks, Ted. So what I'd like to do is just level set on some of the terminology so we have a good frame of reference as a group, and hopefully this will help sort of traverse some of the examples Guru is going to walk through, which I think are pretty amazing. So fundamentally, you have to think about data science as this interdisciplinary science. Historically, over the years, it's been a combination of sort of mathematics degrees, statistics degrees, economics. And as we started to get into the age of computing, that really started to change, and you started to see more computer scientists. You start to see, I have astrophysicists that work for us, and sort of a wider variety of expertise around the table. And that the goal of data science is to be more collaborative, have more collaboration, have better communication across the board, so we can solve a larger set of problems. But fundamentally, it really has to do a lot with what we call data mining and signal detection, which can draw out signals in the data. We can find consistent patterns there. We can then take those and work with the business and understand some of the nuances, because every business has slightly different nuances depending on their operational models and product suites. And then just driving outcomes. So it is a combination of multiple fields. The term has been around since 1974, but really came into play when Davenport and Patel started talking about it in the early 2000s. But it's certainly a growing evolution of the science itself. Machine learning, at its core, you have to think of it as sort of an optimization-based approach, where I've got sort of the sort of combination of good data engineering and good computer science coming together to automate these same things that data science will do. But it's not just the pure automation, it's the optimization, meaning we can now take algorithms that had to take manual inputs to update the models to drive better outcomes for marketing and sales and so forth. And that becomes an optimization because of the automation. And it just constantly learns new information as the data shifts, as those patterns, as I said, and signals shift. You pick up them at scale. And that's actually a very, very powerful tool. We find a lot of success, and we've had a lot of success in my teams over the last 20 years doing that kind of stuff. AI is very much a sort of cognitive-based approach where we're trying to apply it to real-world examples and help inform those decisions for us in a much more robust way. So it's sort of the evolution, in my mind, of what machine learning is, where those decisions are a combination of some cognitive learning, and fundamentally that's where we level set on it. It's a broad definition, of course, but happy to take any questions later. Back to you, Jordan.
Yeah, when we talk about kind of, a lot of the talk about AI and machine learning put into practice for corporate treasury, there's really a small handful of ways that I have interacted with companies around what they're doing, and they really correlate to some of the top priorities of corporate treasury, really for the last half decade to decade. And they kind of correlate back to everything that's going on with corporate treasury, the impact of the tax bill, et cetera. But the number one on everybody's list is always cash forecasting. So, and that, as you guys know, is becoming more and more crucial. And anyone that's tried to cash forecast before knows how difficult it is to put all the pieces together and to even come close to a semblance within a standard deviation. So that's really the number one conversation item as far as how can we put AI/machine learning in place for corporate treasury in an environment where cash forecasting is crucial, right? There's more share buybacks, more dividends, more M&A, more things that corporate treasurers are looking at today because there's more cash in the bank account, especially for the global 100 organizations impact of the tax bill. The second really is around the whole concept of risk, whether that's counterparty risk, whether that's FX risk. It's really how can we put into place some automated processes to help tell us, hey, where is our capital allocated on a time basis, and where should it be allocated? And there's really a lot of focus on the movement of money. Really, the last one that I'd say everybody is looking at is ops efficiency from a treasury perspective. Hey, how can we do more centrally for the business, and how can we do it faster? And I think one of the things that you'll see here from Guru is that they've put at Microsoft into place a lot of things around both cash forecasting and ops efficiency that are really cool. And he's going to outline one of the things today that I think you guys will find really interesting. Back to you, John.
Thanks, Jordan. So let's talk briefly about how you build your strategy as you look at your own organizations and try and solve some of these problems that you're running into, whether it's the forecasting or pure operational efficiencies you're trying to maintain and gain from. And it's really all around using the data with the deep understanding of the business to try and make those more informed decisions on a real-time basis. So, fundamentally, it's important that you really sit down and define your scope and spend just some time with the people doing the work. So there's this sort of pairing and understanding of the nuances. And I think, I don't know about everyone on the phone, but historically we've had that problem where we kick things over the fence. We don't have those conversations, and then we end up with something that's, completely orthogonal to what we wanted from a business perspective or a product perspective or whatever our end state was supposed to be. From there, I think it becomes fairly straightforward to start to delineate what information you want. From a data perspective, I recommend looking at the problem holistically. Even if you have sort of a point solution for a specific problem, if you look at it holistically, that allows you to have what I call a Lego block system for adding to it later. Most of the time when we build something, we're doing it because we think it's going to add value. So we want to make sure that we have the ability to look holistically, understand those dependencies, and we look at how the data has moved forward in the strategy to solve the application problem or the software as a service or the product problem. We want to make sure that we understand all the pieces that go in so we can then move it down the chain. From there, it becomes very straightforward to start testing things, what I call semi-manually. So we get a prototype out, we're testing the output, we're getting validation from the end users. We're taking a good look at our process flow underneath, because what we don't want is something to be built that's important to the business and then be very clunky when we go to implement it. So having some intervention at that point to test this stuff out, to validate, to provide that robust feedback back to the people who are actually building on the technical side is extremely important. And that also ensures that your data architectures, your data flows, can I report off this, even though it's a product? Can I get a deeper understanding of what's going on in the weeds? Can be very straightforward. And typically that's done the way I do it is look at the overall framework that you're trying to look at, end-to-end process. Some people call it a logical design on the tech side, but from a business side, understanding where you can have bottlenecks is also important. And then that will actually help you, because now you've got good collaboration, you've got good communication from a cross-functional perspective, and that absolutely guarantees better alignment and better execution of those things as you push them out to the business. Guru?
Oh, thank you. All right, so from there, why don't we go into a few demos and some hands-on experiences into how we at Microsoft have taken these areas of machine learning and AI and have actually practically implemented it within our treasury. So what you see here is the balance sheet, the latest balance sheet as of 3/31. And the only reason for me to show it to you is how big of an operation that we run here. But we are still a very small team, and we've always been a small team since the beginning. We acquired new companies like Nokia, LinkedIn, but I don't think our headcount has changed that much. And our treasurer, George Zinn, have always told us that the path forward to us, owing to the very fact that we are already a technology company, is that if headcounts don't change and budgets don't change, and the only way forward is technology, right? So that's where we could make changes, leaps and bounds, and we can accommodate for the not so changing budget and the not so changing headcount. And so with that kind of all the ones that have been highlighted is what the Microsoft Treasury kind of manages: the cash and investments and equity, etc. And the operations that we do is something like this. So we get revenue from over 190 plus countries, $400 billion of cash movement on our trading floor every year, and we manage over 2,000 bank accounts, and over 95% of all trades that we do is straight-through processing. And so that's a little bit of what we do here in Treasury. And like I said, we're a small team, so we are over 120 FTEs, and with a few operational vendors is how we run these operations. And so recently, a couple of years back, we've always used this cloud, the productivity cloud called Office 365, but we enabled a few services that were not there before. For example, like Power BI and Microsoft Teams. Power BI is something that I will walk you through in a few minutes. And then we also use this cloud called the Azure Cloud or the IaaS Cloud or the Infrastructure Cloud. And we took Microsoft Treasury into the cloud. So today, all first-party applications that Microsoft builds and manages to run Treasury runs on Azure. All our data is on Azure. They are somewhere between SQL to table storage to data lake. All of that is stored there. And we use a lot of services that surrounds this infrastructure cloud. So together with these two clouds, this productivity cloud and infrastructure cloud, is how we are able to run our operations. And interestingly, it is in this space that we also have these tools which give us the ability to do machine learning, artificial intelligence, etc. So over to a few examples. I'm going to walk you through 3 specific examples. Example number 1 is a chatbot. And so if you think of treasury operations and what we do here, right? One of the things that we take care of is enabling credit for customers. Every customer who has an executive, an enterprise agreement with us, we are in touch with them. And we understand their credit status, extend their credit status, and then actually go back and collect the money from them. So this makes us kind of in the middle for the sales team. During the month ends and quarter ends, the sales team would come back to us and say, how much does my customer owe you? What is their credit status, and what happened to the order that we made, etc. Now, like I said, the preamble that I said that we are a small team, we can't accommodate for a sales force of over 40,000 people. And every time we talk to a sales team member, it is between 5 to 10 minutes of time. And overall, we were talking for many hours during the end of the month. And in the quarter ends, we were talking to them for close to 2,000 hours. Now, what we did was we built a bot. We called it the Edward. And the bot, what it did was it enabled every sales team member, and in fact, even every treasury team member, to ask the question about their customers. So what we did was we did a survey within the treasury, our team, and we took the top 20 questions that they had that they received from their sales teams, and we built an Azure bot by using Cortana, by using the Azure bot service, and we put it into Microsoft Teams so people can just type in the question from where they are. And every time they type in a question, we had a service called Lewis, which is a part of the Azure bot service that comes along. It understands the language and translates the intent. So when you type a question, which I'm going to do in a minute, it translates the question, and then we map it to the appropriate query to hit in our SQL backend, and then you get the answer back. What did this do for us? This basically reduced the number of touch points we had, the number of pings our team would have taken, and the number of queries we would have made on behalf of the sales team, and to find out about where their customers are. And it accounted to over 1,800 hours of savings per month, which was huge for a small team like us. And I would only imagine this would be much bigger if we do the same thing for customers. Remember, this is only for the sales teams. So without much ado, let me just show you the demo of it. So here is our chatbot. You can also add it to Teams, and Teams is a Microsoft persistent chat interface, just like Skype. But just for the demo purposes, I'll walk you through from here. As you would see here, we've been also working on another chatbot called Teresa for the licensing. So if people want to know about what happened to my licenses, is it extended or not, again, for the sales team, we would do the same thing. So the first thing you would do here is probably you would start with the hi, and you would say, and you would want the chatbot to acknowledge to make sure that the chatbot is actually running. And then what you would say is, what's the accounts receivable for? And I could type in any customer name. And if I, let's say, take care of Nestle or Bosch or what have you, you could type in that name. For the purposes of demo, I'm just going to type demo customer. We do have a demo customer record so that we could show these in demo. So what it tells me is that what it did right now is that it understood that I'm trying to get the query for AR. It translated it. It made a query to my SQL backend. In fact, it made 2 queries to my SQL backend, and it came back and it tells me that for my demo customer, whose number is this, the credit limit is 9 million and the outstanding is 8.4 million or what have you. And then there's another demo customer with $90 million, and the AR is even more than that. And then it also tells us, how much time, who has taken, by what segment, and are they 60 plus days delayed or they 0+ days, which is after your credit limit, how long, what is the bucketing for these customers. Now, if I have more questions, I can ask a question like, what's the credit policy? And now the chatbot understands that you're talking about this customer called demo customer, and it gives me a link to the extension policy for this particular customer, or I should say this set of customers. Depending on geographies, customer type, etc., different credit extension policies are there. And you could also find out if you want to make an extension, you can click over to a tool. So we have like I said, we've taken top 20 questions and we have created a bot that would answer these questions according to whatever customer that they type. Now, not only that, we have gone from then on to say we have linked it to our Power BI reporting. So now usually when sales team people come, they don't just want to know these top level details, they want to know more. And so if you click on it, it opens up a Power BI report with the drill through to this exact customer. So this is the demo customer, and now I have all of these balances for the last 3 years. How much money do they owe? What is their AR looks like, and what is their, how much money do they pay us back, etc., and average collections. All of those details are there. Now, with this, that is mostly what the demo customer, or mostly what the sales team members would need for this particular demo customer. But if you are a bigger customer, you could ask more sophisticated questions and all that. And you can also say, so these jokes are not built by us, as you would see. These are basically built by the underlying Cortana system. And so we've just enabled a channel called Joke Channel, and it automatically funnels all the jokes to us. So this, I just wanted to type to say that, you don't have to tell me, you don't have to tell the context. So for the first question, I said, tell me a joke. And then I said, tell me another one. The bot kind of understands, oh, okay, you're talking about the previous, it's a continuation of the previous question that you asked me. So it kind of understands that concept, the context around what I'm asking. So that is a quick demo of how the chatbot is done. If you want anything more, I'll be happy to answer at the end of this thing. But like I said, it's built by using Azure Chatbot service, the Cortana, and we built one user interface and we made it many channels from where you can query. And when I say many channels, you can call this bot through Microsoft Teams. You can call this bot through Skype for business. You can call this bot even through Cortana on your Windows machine. So for here, if I go in and if I bring in Cortana, I can ask the question through, when I talk to Cortana here, I can basically ask the question here as well, if that channel is enabled. So what it means is that you build one bot and you create multiple channels through which you could ask the same question. First demo. Let's look at the second one, slightly more, this one's more easy to kind of understand, and you understand the use case very well. The second one is slightly more sophisticated, so which deals with Power BI. And if some of you might know, Power BI is Microsoft's visualization and reporting tool. Today, 100% of all reporting that we do in Microsoft Treasury happens on Power BI. Just like you, or most of you, we were an Excel farm a couple of years back. These Excels were daisy chained, one connects to another, another connects to another, and the sixth one connects to a database. And when you refresh something on this SQL or this Excel, it would just go back and query it from the SQL. Now, the problem with all of that was that somebody had to maintain these reports and maintain these two-dimensional Excel sheets and all the time have it refreshed, etc. So we moved over to Power BI because we've been looking at waiting for a tool that will let us set us free out of these daisy chained Excel sheets and move on to a much more sophisticated interface. And Power BI came along, and it's interesting that Power BI had great data connectors. That means I can basically get data from anywhere. I could get data as much as simply from a SQL or an Excel, all the way to getting data from SAP or even getting data from Oracle or what have you into Power BI. And you don't have it to move the data, which seems to be the predominant problem of business intelligence, like say 10 years ago. Like what would people do is they would migrate all these data into one common interface or one common data source. They would do what is called as ETL, where they would cleanse the data, enrich it, summarize it, and then they would present it. And Power BI told us, or made it easier, to report data from wherever they are and to give us a common interface where you can sort of cook the data on the fly, create new metrics, and report from there. We adopted it for that, and today every Microsoft Treasury team has a Power BI dashboard. And just to give you an example, and I'll show you a demo, our capital markets team, which was having a 7:30 a.m. call on New York time because we were doing investments, somebody had to come in at 5:30 in Redmond time and refresh these Excel reports, and then have it ready by that 7:30 meeting. So every day we had somebody who had to sort of assemble this report and spend an hour of time just doing this. By doing it in Power BI, today our chief investment officer is able to wake up, just look at his Power BI app on his iPhone, and make investment decisions. And by the time he comes in at 7:30, he is already geared up with the data and decisions to go through the day. And the interesting thing, this analyst doesn't have to show up at 5:30 just to refresh a bunch of Excel sheets. But how did AI or artificial intelligence play a major role in it? Let me walk you through that. So here I am going over to my Power BI example. Now this is Power BI, and I'll just show you how Power BI looks like to start with. So this is Power BI, and most of you who have Office 365 also have Power BI. You just need to know if you have one or not. Just talk to your sales teams if you're a Microsoft customer. But here's our Power BI, and we've created a demo sort of workspace, not to expose production data to demos like this. But each team, this is basically a replica of our production workspace. Each team has a dashboard, and as you see here, there's an equity dashboard, there's a foreign exchange dashboard, a personal spending dashboard, and then a CAPM one. So let me show you what the CAPM dashboard looks like, and before I show you the feature, let me walk you through a little bit of this. So as you see here, right, this is our kind of our investment universe. This is basically all the data dummied up for this particular presentation, but this is our true dashboard. This is how it looks like. Our summary tab, how our credit exposure is. And so the point here is the team has already thought through what questions would our managers or analysts would like to know, and they've built a report based on it. So if I come in here and if I wanted to just look at government spending or how much exposure do I have, I just click on it, and then the whole page sort of updates automatically. So as you see here, the page kind of dynamically updated itself. Now, but that's never the end of the game, right? You would all agree with me that this is never, that nobody could ever think through all the questions that somebody would possibly have. And that is where NLP, or natural language processing, comes into being. Now let me go over to the dashboard again to walk you through that feature. Now imagine our chief investment officer or a GM in the team is looking at this report and he wants to know a certain question. Now he has one option before. He can go to the analyst and say, hey, can you make a visualization for that particular question that I have? And this analyst would spend a couple of hours and he would build one. But what Power BI does is that because we put the data, we make the data available for Power BI to kind of render these charts. It also understands the data that is stored inherently and then lets you ask questions in free form. Think about what chatbot did. Now I can ask a question, it understood my intent, passed my query to the SQL and came back with answers. In this case, it is going to take my question and not only it's going to come back with charts, not just some 2 lines of information like what the chatbot did, it's going to build the chart over the fly. And not only that, it's going to tell me what other questions I can ask. So here I am on the cash on the capital markets dashboard, and I'm going to ask a question. So what's the, and as you see here, it's basically analyzing as I type. So I'm going to say, what's the exposure by, and now it's like, it's already told me what the exposure looks like. Now I can go and sort of pivot this data by multiple dimensions. So I'm going to say by, and now it gives me a bunch of things. But let's say I don't want any of this. I can type whatever I want. So I'm going to say by asset class. There you go. So once I type asset class, then it tells me, oh, you want asset class. Here are various types of asset classes that you have. You can think of, hey, how does Power BI know all of this? All Power BI knows is there is a report called CAPM dashboard, and it's got a bunch of data. And this is how this data is being connected because we built this dashboard within Power BI. By using those connections and those data and that data, Power BI is now able to intelligently understand the data sort of, the formats in which the data connect to each other and lets you ask a question, and it doesn't stop here. So now I basically have an asset class chart that I would have gone to my my analyst to ask him to build it, but now by just typing English I was able to build one. Before I proceed, I wanted to say you can actually take this visual and pin it so that you don't have to ask this question again. I can say pin it to the CAPM dashboard. Let's probably just do it. So let's say I'm going to pin it to the CAPM dashboard. It's already pinned, and I'll show you how it looks like in a second. Then you would go in here and then you say by, and now you can be more sophisticated. So now you're doing what's the exposure by asset class by, and now you can say the issue date. There you go. That's another chart. It may not be that this is the chart that I want. So I can go in and say, well, maybe by country, and it might give me a different chart. But that is just to say that you don't have to do it like this. You can do it by equity subregions. Maybe we don't have that region built. So now this basically enables somebody to say, once you have built your report, now you could ask a question by using AI. Power BI would suggest the different types of questions that you want to ask and different types of charts that you might want to build. So that's one example of natural language processing. And there are others. And if I have time, I'll be happy to run them through. For example, in this data sets, there's something called as quick insights. And this might take time, and hence I don't want to do it for this meeting. But what it does, it analyzes the data sets and comes up with hundreds of charts by using AI that you might actually want. And then you can take one of these charts and then pin it, and then it's always available. And now it says you already have insights. So here is these 100-odd charts that was never intended to be built, but Power BI, just by understanding the data stored behind it, it came up with all of these. And now you can take one of these and say, oh, well, I wanted to pin it to my CAPM dashboard, and it's already there. So now when we go to our main dashboard, you would see that the two things that we created are now pinned here. And so that is how by using a visualization tool and a combination of AI and some part of machine learning that's already sort of built into Power BI, we are able to ask more questions, ask more generic and ad hoc questions, and have it answered. Okay.
Hey, Guru.
So, yes.
Just a quick question. This is Ted. When you go in and those charts have been created, are they then, so that you've pinned them to your dashboard? Are those customizable at that point? I mean, maybe they're not exactly what you had in mind, but they're kind of close to what you had in mind.
Absolutely. So there are great question, Ted. Thank you for that. So there are two ways in which you could edit this. One, you can edit some of the details here, and you can ask, why did I even get this, and what did Power BI think of it in order to give me these insights. The other one that you do is there is a whole other interface called Power BI Desktop, which is more like the creator mode, and this, what you see here, is more of a consumer mode. You can open this in your editor, or sort of the desktop mode, and then edit it to make it work for you. You might change this into, say, a pie chart, and then repin it back here as well. Does that help?
Yes. Yep.
Okay.
Yep.
Cool. So that's just how we use Power BI. But just about Power BI, I could talk for an hour. It's definitely changed how we do our reporting. It's reduced a lot of non-productive hours of our analysts and made them to do more value-added work than just grunt work of refreshing Excel sheets and putting things together. And it actually have made our meetings more productive. So in a meeting, our treasurer or somebody asks a question, what is this? Somebody would excuse out of the room a year back and then go over, run a bunch of queries and come back and answer the question. They may or may not have answers. Today, because we made everybody's team build a Power BI dashboard, the answer is most likely there, or we will ask an NLP question. There are probably 10% of the cases where the data is still not there on Power BI, in which case we still do the whole thing, but it's drastically reduced how we basically run our operations and ask questions. And most of these, as you see here, are available both in the web, on the phone. And not only that, we've taken this and we've thrown it on our televisions, on our trading floor, and now these automatically get refreshed in real time. Okay, so I'm just going to switch over to this next very interesting topic of machine learning. And
actually, Guru, we did have one other question on that.
Oh yeah.
Yeah. So someone wanted to know if the feature, let's see, ask a question feature is native in the Power BI desktop. So is it in there already?
Yeah. So yeah, the Power BI desktop does not have the NLP because Power BI desktop was always meant to be the more of the editor mode. And so when you're the way it works in our team and how all these hundreds of reports were generated, where it was built by somebody on the Power BI desktop, and then they would publish it to this online interface. So if I go over to a Power BI desktop, I would open it up and then I would build this report and then I would hit publish and I'll publish it to what we call as workspaces. So as you see here, we have a lot of workspaces. And so to ask the question, it's not available here because it's by design that this is more for like 5 people in the whole team to work on. They would sit here and they will think about, oh, I need this chart, I need this chart. And then they would build it and then they would publish it. So this is more of a consumer feature. So if you're on the consumption and if you wanted to ask a question, that's when you ask it here. And so that's why it's not available on the Power BI desktop. Okay.
Okay, thank you.
All right. Let me switch over to this machine learning experience that I wanted to talk about. So the third one's probably the most sophisticated of all the three that I'm going to show you, or the two that you saw. The third one is more sophisticated only because of it has to be done by somebody who's a data scientist. I'm actually joking. It used to be that way. And what has happened now is that what happened here, and let me tell you what really happened here, and let you decide who should do it. Now, our analyst always does accounts receivable forecasting. Why do we do it? Because we do foreign exchange hedging, and this helps us a lot to understand how much money at the end of the month are we going to have in which foreign currency. That will help us our hedging business a lot. Now, the analyst would come up with a number, and then he would submit it to his manager, and this manager would think, we'll pad it a little bit depending on what the goal is, and then it'll keep going all the way. When it reaches, let's say, our treasurer or CFO, you don't know in which way it kind of is skewed, right? Now, sometimes these paddings and being aggressive about the numbers are good, but then we always wanted to have this base emotionless number that is pure number that could be removed out of all these kind of biases, is what we would say, and to have a baseline for us to understand from where you go. Now, it doesn't mean that analyst numbers are wrong. Why? Because the analyst has a worldview, looks at what the political situation, socio-economic situation looks like, and natural situations like disasters, calamities, and then makes a decision, right? Wow. So that your machine does not have, at least until now. And so what we have done since then is we partnered with the Azure machine learning team, and we created an algorithm using a bunch of technology, which I don't want to get into today, but just for sake, it's R and Azure ML. Those are the only two that we have used. Now, we used that and we built it on top of the Azure Machine Learning Studio. Now, once we did it, then what we do is we take the real outputs at the end of the month, the actual money that was collected at the end of the month, and feed it. And not only that, we did this, we took the algorithm and we ran it for all the last previous X quarters for which we have data stored. This is called as back testing. So take the algorithm and predict what has already happened. So we go back and say, from Jan to March, how much money do you think we'll have in each currency? And the algorithm would come up with a number, and then the real number has already come out. And now we use that to kind of fine tune this ML algorithm. And it was not like an overnight thing, it was done over many quarters. And in the last 8 quarters, we have to say that the number has consistently outperformed the analyst forecast, and it's become closer and closer to the actual reality, to what it's come to. And so the forecasting numbers, as it says here, it's improved over 6% in the last quarters, which is huge for us. And it's from an FX standpoint, it's like over 25% of an impact of change in how much income we made for this particular this business. So that has definitely changed how we think of machine learning and how we should basically adapt it in other areas. So today, most areas in Microsoft, in finance, like cash forecasting and short-term, long-term, sometimes even sales and revenue numbers that we talk to the street, are all being predicted by machine learning algorithms, which are then validated by analysts because they, like I said, they have the other view. And then we supplement both of these and then come up with a number that we'll then take action upon. So here is one such algorithm that I wanted to show you. So this is the experiment. And first I'll just show you the experiment and then we'll walk you through what it looks like. So as you see here, we've been having a number of these that's been run. So this was run kind of yesterday for July for AR. And if you look at it, right, and this is more of like how the back end looks like for this. So this is the Azure Machine Learning Studio. And on the left, you have all these open kind of libraries, I should say, that would be more like a drag and drop and then connected. So if you come in here, let me just expand this for a second. Okay, so in this example, we purely read from a CSV file. We edit some metadata, we pull some columns into a data set, and this is where I said this is Azure ML, but then we also have an R script that does a bunch of joins and scoring of an algorithm, and then at the end of it you would have a web service output, and then you'll have an output as a CSV as well. The web service output is only because now you can run this data, run this algorithm on demand, and not have to necessarily do it, come in here and basically say run the algorithm. You could do it in other ways, which one of these ways I'll show you. The interesting part of how this was made easy for us was, if you come here on the left side, these are the machine learning, the core tenets of machine learning. You would evaluate it, you would initialize a model, you would score, and then you would train it. And then, or train and then would score it. So if you come in here, you take any one of these, like for example, a clustering model, you would be able to drag it and then connect it to any of these and then keep going. The train clustering model itself has a small code that's already pre-written by Microsoft ML, and you don't have to pre-write it. Now, if you want to override it, you can always do that. But then you can also use what is already given for you to just keep changing. I'm just going to delete it without making any problems for the analyst. So what I wanted to show you was slightly a different one. So let's say we're going to start a new experiment, right? To start with the new experiment, you don't, what I was trying to say earlier was that you don't necessarily need a fully trained machine learning expert to start with. We had an analyst who was interested in data science and who took a couple of classes, and that's all we had. And then he was able to come in here, at least start the experiment and run some basics. And when he got stuck, then he sought help from an ML in order to write R and things like that. But if you want basic algorithms, most of them are kind of pre-written. For example, let's make a question for movies. For examples, right? Movie recommendation, like you would have seen it in Amazon or Netflix, right? You would watch a movie and then it'll tell you, here are the other movies that you might actually like. That is nothing but an ML algorithm for which we already have a predetermined algorithm template written for you. So this is that template. And as you would see here, what it's basically doing is it's basically taking IMDb details, joining the data, and then removing some of the duplicates, and it runs a training algorithm called train matchbox recommender. It's a one way of how you take two inputs and then you come up with a recommendation engine for it. And then at the end, you have a recommendation. So say you're a company and you wanted to create a recommendation for a set of products. It could be an insurance product. It could be a finance product. You could use the same template and then you could go from there. And then all you need to do is to save it into your account and then run it and provide appropriate inputs. You would have your answer or your training engine already set. It's that easy, was my point. So now let's go over to, and I'll walk you through the example that we built initially, the experiment to do the unbuild or the build AR forecast.
So Guru, when you walk us through this, we're going to have to get to some questions that we have coming in.
Sure. So this will take a minute. And so as you see here, right, like I said, we created a web service output there. What would that mean? Because now I can take an example of 5 years worth of accounts receivable data in GBP, Euro, and Australian dollar, starting from 2011 to 2017, and now send it to that algorithm and have it scored and tell me how much money would I make in a certain currency for the next 3 months. Again, demo data, but this data is in millions. Now we have an Azure machine learning plugin for Excel that you can always download it from the store, and it'll show up here. So if you go to the store here and you basically type in Azure machine learning, it will show up for you. You can install it. So I'm going to make this happen, which is I'm going to take this data set for 5 years, send it, and get back my data. So here I'm saying what my input is. It's from A1 all the way to the last line, and then I want my output in 221 or G1. So when I say hit predict, what happens is that this data is sent to that same algorithm that I just showed you. and it comes back with data in a matter of few seconds, because it's like probably 200 rows of data. It doesn't take that long. But importantly, what it tells us is that for the month of June, in Australian dollar, the lower confidence interval is $656 million. The upper confidence interval is 855, and the actual forecast is 755. Now here's your lever, right? The same thing that I was saying, somebody would be aggressively forecasting, somebody would be much more lenient towards it. This gives you the swing. This tells you, if I were to be very aggressive in collecting money, we'll make $855 million. If I'm not so much aggressive, if I'm kind of expecting people not to pay on time, it's going to be 656. But by looking at past data and past performance in Australian dollar, I think we're going to make $755 million. That is just the idea. And now the analyst uses these three outputs, or these three data points, and then decides what he feels. He might actually say we'll actually make $700 million. That's up to him. But then the machine tells you 755. So we compare both 700 and 755, and then we'll watch for what happens at the end of the month. And that's how this data is being used. The more the data you send, the better your number becomes, is another thing that we have understood from it. And the one thing that I wanted to say before I end this is that for any machine learning product or project, you would need enough time and enough training of the algorithm and fine-tuning of the algorithm before you get anything worthwhile for you to actually use in practically, because these are big numbers and we are going to make a big impact in how we do business. And so give it enough time, run it over a period of time, and keep back testing, and then you'll fine-tune your algorithms. Over to you, Ted, or for any questions.
Okay, great. Thanks so much, Guru. First question is actually for John. If your data is coming from different sources, how do you consolidate it into one database?
Good question. It's fundamentally a fairly straightforward process. Whether you're in the cloud or have local hardware on the ground or your own data center stuff, the fundamental pieces are looking at the entities you want to make sure that map together. So just do some spot checking to make sure this company is the same company. We generally call that entity resolution, but it's you can start rather quickly on it. But the power of some of these distributed systems and everything we have, you want to put in some SQL environment so you can report on it easily, so it doesn't take a data scientist to pull something off Hadoop or Spark or something like that. But it is pretty straightforward if you just have basic requirements and start to put it together. The last piece I would recommend considering is third-party data to provide insights into the narrative. So most of us can get really good signals from our own data, but there's always going to be sort of, I don't know, we don't have that data or that view. So telling that narrative to make more informed decisions can generally be done through some basic third-party acquisition.
Great, thanks, John. I think we have probably time for one, maybe two questions, but another question's for any one of you. We've heard mention that machine learning can solve formerly unsolvable problems. What would be a good example for Treasury? What unsolvable problem should Treasury tackle first? If there's an example. Jordan or John?
Yeah, I think one of the first things, and one of the things that I mentioned and that Guru outlined, one of the things that they were doing was trying to solve through his accounts receivable tool, is how to solve both the cash forecasting problem and then the interlace in between the FX hedging, and just kind of forecast how much cash you're going to have coming in, and making sure that your positions are correct at any given point in time. And that's been one of the challenges through the years, is trying to forecast those inflows and outflows. And I think that's one of the first places that you can start to say, okay, based on the cyclicality of our business and based on kind of the mix of customers that we have coming in, can we build something that takes that into account on an automated basis? And that's more in the machine learning space where you're saying, hey, as the business grows and as different factors within the business are changing, can we have something automated, whether it's through the cloud, like Guru outlined, or whether it's through something on-premise. I think there's things that can be built there that are fairly rudimentary that we've seen.
Okay, great. Thank you, Jordan. So I think that's all the time we have today. So thanks everyone for joining us. Thanks to the panelists, Guru, excellent presentation. And again, there'll be a follow-up email with the slides and a recording. Thank you all for joining us. Have a great day.